Hello, my name is Hernandez, and I was one of the two contributing team members to Snackability 1.0. So this is the introduction video where I will give a run-through of the problem statement, current solutions, and the solutions that we've devised for Snackability. So Snackability revolves around categorizing snacks, giving good snack scores based on USDA research guidelines. Why we need to do this is some of the concerning results in studies done by teens and young people consuming snacks. So some of the USDA studies show us that 83% of adolescents consume snacks daily at 1.7 times per day. 98.2% of college students consume snacks daily at 3.9 times per day. Most of these were deemed unhealthy according to USDA guidelines. So to have some background definition on what the proper accordance of a snack is a portion of food smaller than a regular meal, generally eaten between meals. Snacks come in a variety of forms, including packaged snack foods and other processed foods. To the right, you'll see a table delineating what a smart snack looks like. So we looked at a whole bunch of current systems and applications. We researched about 22 applications in the market that give similar metrics on snacks, nutritional information, but we found that none of the applications based their results on the USDA guidelines, and many of the applications rely on unchecked user entries to provide nutritional information about snacks. So, with that in mind, we decided to build Snackability, a user-friendly mobile app whose main purpose is to allow users to search for snacks and easily know how healthy a snack that they're searching for is. We built a web API backed by a large data source and a curated local database. So the large data source is the USDA's branded food and standard reference database, as well as a database we built with the Department of Dietetics and Nutrition. And we also built a React Native mobile application that can compile down to both Android and iOS. So here you'll see to the left some of the mockups of the initial application. So here you can search for applications, and a list of the snacks will appear. You click on it, get the snack detail view. Here you can see the recent snacks, your settings view, and this is kind of the app info view. To the right, you'll see one of our proof of concepts, which is a GIF of a simple web page to test feasibility. Here, you see a user inputs the name of a snack, and it generates an entire nutrition label for the snack. So that was interfacing directly with the USDA API to show if this was possible, what kind of information we would get from the USDA. So this was very much a proof of concept of this application. So this was what we actually used to implement the app. We used React Native, Redux, Firebase, Node Express, Heroku, and MySQL. And this is the application overview. So essentially we have Redux for complex state management inside of a React Native application that compiles down to both Android and iOS. And we leverage Firebase for authentication and account data store. And on the back end, we have a Node Express MySQL setup where we are interfacing with the local curated database as well as the USDA API, and have the scoring algorithms for conversions of different snack portions, and we have that API deployed on Heroku. The React Native application connects to that API. When a user continues a search, it will query the API, bring back the results, and allow the user to store if they've eaten the snack, and that happens on the Firebase account data store side. We also started on some administrative functions, so basically a web page that will be connected to the web API to allow administrators to do CRUD operations on the MySQL database. So this is one of the earlier use case diagrams. As you'll see in some of the further documentation, we continue to add more stories and add more features for the actors. So unregistered users will essentially register, log in, then they consult their history, search for a snack, send email suggestions for a snack, have the app information. They'll get snack detail, score, feedback, as well as being able to suggest new snacks, and administrators can update SnackDB and receive emails about new snacks, as well as check the snack history of users. So this is the current state of the application. As you see here, we went for kind of a material design look, and this is the application currently on iPhone screenshots. It also works on Android as well, and you can search here. This is a simple search feature. If you click the plus button, you would toggle the advanced search that allows you to enter some information on whether the app is processed and some portion-sized information. You'd hit search and get a results list of all of the snacks matching the criteria these are entered. You would then click on one of these list results and go into the snack detail view. Here in the settings, you have the ability to add a snack and submit some feedback. We also created an info page to list all of the members who have worked on the project, and talk about some of the information related to how the application works, the USDA guidelines. So this was an earlier render. Now there's more information on these, and you'll see that in the later documentation and videos. So some of the verification, this will be important to you all, is we built the initial proof of concept that was shown earlier in the video, which is kind of this GIF here, where we're showing you on a web page that's leveraging jQuery to query the USDA API and build everything into this nice responsive nutrition label we built. Some of the other things we have a series of Postman tests that target both the local API as well as the API when it's deployed, and we did write some Mocha chai strips that were used to unit tests used to test for conversions and some of the aggregations, and as well as we checked back a lot with the Dr. Christina Palacios and the rest of the research team to make sure that when questions about ingredients came up or scores or how the scoring algorithm was worked, we worked a lot in defining the algorithm with them. So we had a lot of kind of manual checks done in that way, as well as we tested the application on a variety of different phones. So in summary, the objective was to design an app that uses USDA guidelines to provide a numeric score based on how healthy a snack it is. This is the first release, and there will be an initial on-campus test sometimes during the summer, and there's a lot of space for this application to grow. Especially, I see a lot of space both on the front end. More features can be added, but as well as on the back end with data parsing, data cleaning, and as well as maybe even leveraging some machine learning, something like linear regression possibly, or some sort of classification algorithm, so that you can just pass in all of the features of the snack and the algorithm will get better and not be maybe so overfitted, and grow, especially with higher portions. So the application has a lot of space in pretty cool new backend web structures, new React Native, so mobile and iOS development, as well as kind of the big data aspect. So yeah, that is the introduction of Snackability.